Welcome to the HT8 MCU Basic Tutorial. In this session, we will be exploring comprehensive experiment basic knowledge. This course will be explained from the following four aspects, which are comprehensive experiment introduction, hardware preparation, development environment setup, and program example download method. Comprehensive experiment introduction. Each experiment is divided into the following 5 aspects, and a detailed introduction of each aspect is as follows. Experiment introduction. It explains the content of the experiment. Hardware connections. Design suitable hardware circuits based on the experiment requirements, and learn about hardware connections, etc. Program development. Determine the programming logic and algorithms for the software based on the experimental objectives and hardware circuit design. Practical results. Check whether various functions can be implemented as expected. Experiment summary. Consolidate and review the relevant knowledge points covered in the experiment. The experiment objectives are as follows. Deepen theoretical understanding. Through experiments, previously learned theoretical knowledge can be integrated with practical operations, helping users understand and master these concepts more intuitively. Develop practical hands-on skills. The experiment requires hands-on involvement in operations such as connecting hardware circuits, developing software programs, and debugging. In this process, we become familiar with the characteristics and usage methods of various electronic components, master the skills of circuit board design and fabrication, and enhance our ability to solve practical problems. Master the use of development tools and software. Helps us learn and master the operation methods of these tools and software during the experimental process. Hardware preparation. The hardware required for the comprehensive experiments includes the following. It includes DEV3195 development board, emulator, serial port module, breadboard, LED, potentiometer, common anode digital tube, key, capacitor, resistors, Type-C cable, connection wires, and other components. The DEV3195 development board and emulator can be purchased on the official website of BEST module, while other components should be procured separately. Other hardware specifications should be prepared independently according to the instructions provided for each experiment. Let's take a look at the breadboard. In the upper and lower sections, 5 holes in the same horizontal row form one connected group. Adjacent groups are continuously interconnected, typically in sets of 3 or 4 consecutive groups. In the central section, the 5 vertical holes in each column are electrically connected. Components should be placed straddling the central isolation groove. Different breadboards may have varying designs. Please verify based on the actual product. The experiment uses a common anode digital tube. An introduction to the common anode digital tube is provided below. A common anode digital tube refers to a type where the anodes of all 8 LED segments are connected together. The schematic diagram of the 2-digit digital tube is as shown below. The specific digit to be displayed is selected by controlling the DIG1 and DIG2 pins, while setting the other pins to a low logic level to light up the corresponding LED segments. Below are the pin diagram of the 2-digit common anode digital tube and the schematic of the corresponding LED segments. Based on the arrangement of LED segments inside the digital tube, the MCU controls the pins of the digital tube to display digits 0 to 9. The truth table for a common anode digital tube is shown below. Let's look at an example. Assuming we want to display the number 2 by setting the corresponding pins to a low logic level simultaneously, the relevant LED segments can be illuminated. This driving method is called static display, also known as DC drive. Let's learn about the time multiplex driving method of digital tubes. The schematic diagram of the digital tube is shown below. A resistor is connected to the comms to achieve current limiting. Because only one resistor is used, when driven in the DC mode, it can cause inconsistent brightness of the LEDs when displaying different content. Therefore, a time multiplex driving method is adopted for this experiment. Only one SEG is lit at a time to ensure consistent current for each SEG, guaranteeing uniform brightness for each LED segment. In this experiment, the output switches to a different SEG every 2 milliseconds. For example, when displaying the number 8, the control pins of the digital tube are as shown in the diagram below. Next, let's introduce the key and its debouncing. The switch used for the key is a mechanical elastic switch. When the key is pressed or released, the switch contacts will experience bounce at the instant of closing or opening, as shown in the figure below. Generally, the bounce duration is 5 to 10 milliseconds. A delay function is used to eliminate this bounce to prevent erroneous actions by the MCU. In this comprehensive experimental course, we'll cover 2 commonly debouncing methods for your reference. First, delay debouncing, and second, timer debouncing. Development environment setup. Let's take a look at the development environment. The development software is HT8 3000. The development tool is the E-Link Pro 2 emulator and the main control board is the DEV3195 development board. The connection between the E-Link Pro 2 emulator and the DEV3195 development board is shown in the figure below. For HT8 3000 and E-Link Pro 2 tutorial videos, please visit the Holtec channel on the Holtec official website. Let's review the HT8 3000 main interface consists of the following parts, including the workspace, the editor area, and other functional areas. The DEV3195 development board includes an E-Link interface, a micro USB interface, a power indicator, a 3.3-volt LDO, a LED indicator, a power selection circuit, I/O pins, and the HT66V3195 main control MCU. Most MCUs do not have integrated emulation capabilities. Their corresponding EV chips have model identifiers that can be associated with the MCU being emulated. For example, the general-purpose 8-bit MCU HT66F3195 corresponds to the EV chip HT66V3195. Program example download method. Please log in to Holtec's official website and download it from the application notes for 8-bit MCUs. Holtec has a professional service team to assist in development design and after-sales service. Please feel free to contact our business departments for more detailed product information and consultation services.